Hello, welcome to our video presentation. This report focuses on the engine, the Allison 250-C20. In this presentation, we will discuss its operating principle, its major and minor components, as well as its maintenance practices, including disassembly and assembly procedures. Now, let us move on to the first part of the discussion. For the first part, I will be discussing the operating principles of the turbine section of the Allison 250-C20, and I will also briefly discuss how the turbine works and compare it to other types of gas turbine engines. So, in this slide, the turbine section converts thermal energy into mechanical energy. In simple terms, yung heat and pressure ng gas from the combustion chamber kino-convert into rotation or motion. So basically, dito nagagaling yung power ng engine. So how it works? How does this turbine work? It uses hot, high pressure gas which expands, speeds up, and then hits the turbine blades, causing them to rotate. And the turbine operates based on two main principles. Firstly, we have thermodynamic expansion and aerodynamic coupling. I will explain them one by one. First, thermodynamic expansion. After combustion, the gas enters the turbine at very high temperature and very high pressure. As the gas flow through the turbine, it expands. Habang nag-expand siya, the pressure decreases, the temperature decreases, but the velocity increases. So ang result, the gas becomes fast-moving and energy-rich. So let's move on to the nozzle guide vanes. In this slide, before the gas reaches the turbine blades, it passes through the nozzle guide vanes. The nozzles accelerate the gas and direct it at the correct angle. They also convert thermal energy into kinetic energy. So they ensure efficient impact on the turbine blades. And now, turbine blades or energy conversion. Now, in this part, the high-speed gas hits the turbine blades. This force makes the blades rotate, producing shaft power. So, habang nawawala yung energy sa gas, napupunta naman sa turbine sa mechanical motion, And aerodynamic coupling. Aerodynamic coupling or the free turbine system. There are two turbine sections. The gas producer turbine and the power turbine. They are not mechanically connected but connected through the gas flow. And let's proceed to the gas producer or GP turbine. In this slide, the GP turbine is connected to the compressor. Its function is to drive the compressor, maintain airflow, and then combustion stable, and to keep combustion stable. So without this, the engine cannot operate. And let's proceed to power turbine or PT. Next, the power turbine, this is connected to the output shaft. It converts remaining gas energy into usable power. So this is the actual output power. Now, for a short comparison, the Allison 250-C20 uses a free turbine design where the gas producer turbine and power turbine are separate compared to other gas turbine engines such as single shaft engines. All components are mechanically connected on a single shaft. So in free turbine system, mas flexible yung operation kasi kahit magbago yung load, hindi agad affected yung buong system. Maganda ito for helicopters kasi kailangan nila ng smooth and controlled power. While in single shaft engines, the design is simpler but less flexible in operation. So, for the final slide, fuel is burned producing hot gas. The gas expands, nozzles accelerate and direct it. The gas hits the blades, causing rotation. And the same gas drives both turbines. So the final output is mechanical power. That's all for the operating principles of the turbine. Thank you.
Good day, everyone. Today, I, Miguel Angelo Carasig, I will be discussing the turbine section of a gas turbine engine, specifically focusing on its components and their functions. The turbine section plays a critical role in converting the energy from hot gases into mechanical power. First, the turbine nozzle. First, we have the turbine nozzle, also known as the stator. This component is made out of a stationary vanes. Its main function is to direct and accelerate the hot gases coming from the combustion chamber towards the turbine blades at the correct angle. This ensures the maximum efficiency in energy transfer. Second, we have the turbine wheel. So next is the turbine wheel or rotor. This is a rotating component with blades attached to a disc. As high-speed gases hit these blades, they cause the turbine to spin. This spinning motion is what generates mechanical energy used by the engine. Third, we have the turbine shaft. So the turbine shaft connects the turbine to other engine components. In engines like the Allison 250, there are separate shafts. One shaft drives the compressor while another may drive the power of the turbine. This setup improves efficiency and allows independent operation. Power turbine. The power turbine, also called as the free turbine, is especially important in the helicopter engines. It is not directly connected to the compressor. Instead, it extracts energy from the exhaust gases and uses it to drive the helicopter's main rotor through the transmission system. Bearing and seals. So bearings and seals support the rotating parts and ensure smooth operation. Bearings reduce friction, while seals prevent oil leakage and maintain proper airflow inside the engine. And exhaust section, which is the last part. Finally, the exhaust section allows the gases to exit the engine efficiently. It also helps maintain proper airflow and pressure balance within the turbine section. So, in summary, the turbine section is responsible for converting thermal energy into mechanical energy. Each component, from the nozzle to the power of the turbine, plays a vital role in ensuring efficient engine operation, especially in aircraft and helicopters. And that's it for the turbine section as I pass you on to the next presenter.
This part of the report discusses the safety protocols upon dealing with Allison 250C20 engine. But before maintenance execution, safety must be our number one priority because skills cannot be applied without its mechanic. So, use proper personal protective equipment or PPEs such as aprons, gloves, and goggles. Be cautious of hot surfaces and pressured systems. Follow proper cleaning and fire safety procedures, especially when using chemicals. After making sure to keep this in mind, let us move on. The manual emphasizes that all personnel must strictly observe warnings, cautions, and notes before performing any procedure. That is why maintenance must be performed using approved methods, tools, and materials only. The engine must be in a safe condition, shut down, and allowed to cool before work. All airframe and engine interface connections must be properly secured or disconnected when required. Failure to follow these instructions may result in damage to equipment or injury to personnel. According to engine servicing procedures, only specified consumable materials, lubricants, and hardware must be used. Correct torque values must be applied during installation of components. Proper procedures for lock nut installation, fittings, and tube connections must be followed. Components must undergo inspection and checked to determine serviceability. The manual also indicates that parts showing wear, damage, or corrosion must be replaced. Maintenance must follow the prescribed inspection and troubleshooting procedures. an important thing sa pandiak. The manual highlights the importance of proper cleaning procedures to remove contaminants, application of corrosion protection, and surface treatment when required, use of approved cleaning agents and fire extinguisher materials. And for storage and handling, components must be properly preserved to prevent deterioration. Engines must be prepared following preservation and storage instructions. Now, allow my companions to discuss the process of disassembly and assembly of the engine.
Now moving on to disassembly procedures. Step 1, we have engine preparation. We begin by preparing the engine for safe disassembly. First, the engine is securely mounted on a stand to prevent any movement. All external connections are then disconnected, including oil lines, air lines, and electrical wings. At this stage, it's important to label components to avoid any confusion during reassembly. We also make sure the engine is clean and free from contaminants. Remember, safety is always the priority, so proper tools and protective equipment is a must. Step 2. Remove all external housing. Next, we remove the external housing to access the internal components. This includes removing the combustion liner and turbine casing. These parts are carefully loosened and removed in sequence to avoid distortion or damage. Once removed, the internal sections of the engine, especially the turbine, are exposed. At this point, we also inspect the visible components for wear, cracks, or carbon buildups. Step 3. Gas producer removal. In this step, the gas producer turbine is carefully removed. This is critical and delicate component, so special tools and fixtures are used to maintain alignment and prevent any excess damage. Extra care is taken with the turbine blades, as even minor damage to the blade tips can affect the engine in the long run. The components is handled gently and placed in a secure, clean area after removal. Moving on to step 4. Power turbine removal. After the gas producer is removed, we proceed to the power turbine. The power turbine is separated from the exhaust collector and the output shaft. This step requires precise handling to avoid misalignment or damage to the shaft. Proper support tools are used to ensure the turbine is removed smoothly without applying unnecessary force. Last step, step 5, bearing and seals removal. Finally, we remove the bearings and seals. Specialized pullers are used to safely extract these components without damaging surrounding parts. Remember, it's very important to protect the shaft surfaces during this process, as scratches or dents can lead to future mechanical failure. All removed parts are inspected, cleaned, and properly stored for future evaluation or replacement. Now, to summarize, the disassembly process must be done in a careful step-by-step manner, ensuring safety, proper handling, and protection of all critical components to maintain engine reliability.
Good day everyone. Now I am discussing the assembly procedures for the turbine sections of the Allison 250 C20 engine. Before we begin, we must ensure all the components have passed the NDT inspections and that we are working in a clean room environment. Strictly adhere to the torque values and one-time use hardware requirements specified in the overhaul manual. We begin with the gas producer support. First, install the non-amplified bearing into the GP support housing. Ensure the race is properly seated. Second, apply a light film of turbine oil to the seals. Third, position the GP turbine support in the assembly fixtures. We must ensure the all jets are clear and unobstructed, as lubrications at this stage is vital for the high RPM cooling of the GP rotors. Now we move to the hot and rotating components. First, slide the first stage turbine wheel onto the main shaft, followed by the spacer. And second, install the second stage turbine wheel. Note the curved couplings. This must be perfectly aligned to ensure balanced rotation. Secure the GP tie bolt. This is a critical step. Use the specified stretch measurement method or torque turn method to ensure the rotating group is clamped correctly. A loose tie bolt can lead to catastrophic engine failure. With the rotors in place, we install the stationary beams. Position the first stage nozzle. This component faces the highest thermal stress. Ensure the mounting lugs are not cheap. Install the second stage nozzle. Check for tip clearance using a feeler gauge. Verify that the gap between the turbine blades and the nozzle shroud meets the manual minimum and maximum limits. If clearance are too tight, thermal expansion will cause rubbing during operation. Next, we assemble the power turbine section, which consists of the third and fourth stages. Install the PT support assembly and number 6 and number 7 bearings. Insert the power turbine shaft and mount the third and fourth stage wheels. Unlike the GP sections, the PT sections operates at lower speeds but handles the high torque required to drive the gearbox. Ensure the internal lines lubricated with the approved anti-seize compound. The final steps involve sealing the unit. Install the turbine outer shield and the exhaust collector support. Make the turbine sections to the compressor gearbox. Carefully align the spline drives. Install the V-band clamps. Ensure the T-bolts and torque safety wire. Perform a rotational check. Manually rotate the N1 and N2 systems to ensure there is no binding or unusual noise before the engine is sent to the test cell.